what does the universe look like? What is the shape of the universe? Well, I guess a lot of it depends on if you're talking about infinity, if it's infinite, and if it's just big. Big means it has size, means you can talk about the shape of the universe. Infinity, what does an infinite table look like? Right? That's the question. And I don't think infinity has anything to do with shape. In fact, if it's infinite, whatever that means, I don't think you can have shape. Okay? So we have to separate those two. So here is the question: is the universe finite or infinite? Most people believe that the universe is infinite. Okay, but mathematical physicists, right, talk about shape of the universe and how big it is. Well, if it's got shape, it's finite, and if it's big, it's finite also. But if it's infinite, then it cannot have shape. You cannot talk about the shape of something that is infinite. In fact, it's a contradiction in terms that we will find out, because a thing, object, is that which is finite. And so you're saying it's an infinite finite. That's what you're saying when you're saying that an object is infinite. Okay. Anyways, infinite means no shape. Okay. And if the universe is finite, you must illustrate it. That's the only way. You show us what you have in your mind. Okay. So give us a picture of it. And if you do that, you got to do one more step, and that is you must identify the medium that gives shape, contrast, right, to the universe. So there you have a picture of it. If the universe is like that, that's just an example, right? What's the black stuff that gives shape to, or contrast, right, to the universe? Those are your tasks. If you can't do that, you don't have a starting point. You don't have a hypothesis, let alone a theory. Okay. Okay. So here we move on. This is how we do it in rational science. Okay. We say hypothesis. It's an assumption, the set of assumptions. And it's the objects, the definitions, and what we call the initial scene or statement of the facts. What is that? Well, you got to show us what your starting point is, where your movie starts. You got to have a first frame in the film. Okay, you can't start in the middle of the film and tell us about some theory there. No, you got to start in the beginning of the film, right? First frame, and then you're going to build your theory on that initial scene. You got to paint the picture of what we're staring at, right? We're only human. Some of us. Anyways, and then you can explain the theory, your mechanisms and causes. Again, this is for purposes of physics. And then you see the first golden principle of physics. Okay, you can't do physics without objects. If there were no objects, there would be no phenomena in the universe. There would be nothing to see, nothing happening. So you had better have objects to do physics. Okay? And the mathematicians, who call themselves mathematical physicists with quotation, they never understood that. You need objects, and they don't deal with objects. They deal with concepts. They talk about field, they talk about mass, they talk about energy. None of those are objects. None of those are things. Thing that which you can illustrate. And I challenge anyone to illustrate energy or mass or time or whatever. And that's where the problem is, the language. Okay? Okay, so in science we hypothesize, right? We have to give an assumption. We start with an assumption. And hypothesis, again, supposition, right? In science we define strategic terms. What are the strategic terms for physics? The first one is something. What is a thing? What is an object? And it's that which has shape. It's not that which we can touch. It's not that which we can see. It's not that which is made of atoms. None of that is a good definition of the word object. Object, that which has shape. Something. What is nothing? That which doesn't have shape. See how easy it was all these years? So they're antonyms. One is the opposite of the other. Shape, no shape. Simple. Very, very straightforward. Now we can use those words consistently, rationally, scientifically. Okay? And there we have it. Synonym of nothing, space, vacuum, void, emptiness, etc. Okay, so you can't make an assumption in science, in physics, right, that a thing is infinite. Why? Because it violates the definition you just gave. Something, that which has shape. So you can't say that my assumption is that this thing which has shape is infinite. No, you can't say that. if it has shape, it better be finite. It better be surrounded all around with some kind of skin. Okay? And obviously, you have to identify the backdrop, what's behind it. What gives it contrast. And so there's no such thing that is infinite, right? And definitions are crucial to talk intelligently. If you don't define, we have no idea what you have going through your tiny little brain. Okay, so here we have some of the problems we started out with when we started this human thinking, human reasoning, you can say. And it started with the Greeks. They didn't do a good job at all. And they set all the mathematicians on the wrong footing. That's what happened. And here you can see it, okay? This is good old Euclid, okay? He wrote a book about 200 BC, and here it is, a figure. I'm just looking at a couple of the things that concern us right now today, right, for this lecture. So definition 14, a figure is that which is contained by any boundary or boundaries, okay? So what's a boundary? Well, you look at the previous definition, number 13, it says boundary is that which is the extremity of anything. So we have a circular definition there. We say, what is a figure? Is that which is surrounded by a boundary. What's a boundary is what surrounds a figure. Great, Euclid. Great job. Okay, so Euclid did not start off on the right foot. And because of that, all the mathematicians just left it at that. They never worried about definitions, and that's why we ended up with the nonsense we have today. And here we have just a criticism of that, okay? What is a line? Well, it's contained by a boundary. And it's not what Euclid said, which is endless breadth. Okay? No, endless breadth is not a good definition for a geometric figure. Because according to Euclid, it's got to be contained by boundaries. And if it's endless breadth, it's not contained by boundaries, period. So it's a contradiction there, and you have to fix that problem before you can continue, okay? In physics, line is just an elongated rectangle, and it's not made of points like you see there. No, all figures are made of a single piece in physics. An elephant is made of a single piece. Table is made out of a single piece. Tree is made out of a single piece, so is rock. You can't say a rock is what is made of atoms. No, that's not a definition of a rock. Rock is what I point to. Okay, you point to objects in physics. You point and name so that E.T. learns your language. Here, the Klingon, he visits us, and you point and say table. Now he knows what the word table refers to. That thing you pointed to. You don't say, well, it's a gazillion atoms. No, that's not a table. Because gazillion atoms is also an elephant, a tree, a rock. All of it is a gazillion atoms. But we don't care what it's made out of. That is Mariology. Mariology is religion of the philosophers. Okay, we don't use Mariology in science. In science, we have the point and name. Okay, that's how you present an object in physics. And if I point to a line, what's in front of you is a stick, a two-dimensional stick. That's what a line is, because that's objectively what's in front of us. At least two-dimensional or three-dimensional, never one-dimensional. There's no geometrical figure that is one-dimensional or zero-dimensional or four-dimensional. There's only two- and three-dimensional figures, objects, things, right? And the only ones we use in physics are the 3D ones. We don't use the 2D. Those are conceptual figures only. Okay, so line is not infinite. Okay, like Euclid said, endless breath. My breath. I'm running out of breath. Okay. Now, line cannot be infinite. Okay, that's not a figure. Okay, and it's the religion of mathematical physics who invented the infinite line. And they're not talking about line. They're not talking about figures. They're talking about numbers. They're talking about incessant growth, or incessant counting, or incessant whatever, perpetual whatever. They're talking about something else. And again, you can't unite math with physics. They're irreconcilable, okay? And that's what geometry was. Geometry was the first attempt to unite physics with math, math with physics, and that's where we ran into trouble. You cannot do that, okay? Math is math, physics is physics, never the twain shall meet, okay? And so Euclid went on to the plane, and he defined it as such. He says, a line is breathless length, and the ends of lines are points. And then he says a surface, meaning a plane, right, is that which has length and breadth only. Okay, length and breadth, square, circle, or disc if you prefer, or triangle. Yeah, those we understand. But he says, number 6, keep this one in mind. The edges of a surface are lines. Okay, so if a surface, meaning a plane, is lines, well, it's very simple. Okay, that means that it's got to be surrounded all around. There's no infinite plane. But that's what people repeat, today without any understanding, obviously. And so here you have the problem. Plane is a figure. Okay? No matter which plane, I don't care if it's a square, a circle, or a triangle, or whatever. It's a figure. And if it's a figure, it better be surrounded, all around by lines. That's what Euclid said. Okay? It's contained by a boundary. And in physics, circles, discs, squares, triangles, all have boundaries. There's no such thing as an infinite triangle, infinite square, infinite circle. No such monster. Okay? And so planes are not infinite. There's not a single plane that is infinite. But what they've done, because they're not doing physics, they're not doing the real physics, they're trying to do math, and they say, well, what if we extend the plane? Well, you can't. Because the plane, no matter how far you extend it, we better be able to see it from a bird's eye perspective to know that it's a plane. Otherwise, you have no idea what you're staring at. Okay? And again, they took away the visualization and they started doing math. That's the problem. And they introduced math where math was not needed. In other words, they confused the math with physics. Physics is physics, math is math. Keep them separate. They never should be mixed. Okay? And so it was the religion of the mathematical physicists who merged math with physics. Okay? And yeah, what they're talking about is itinerary. They're not talking about a figure. And that's where the problem is. They're talking about trajectories, motion. And so unless you put it in the right context, you will not understand what these people are doing. Okay, and same applies to solids, by the way. Here you have the infinite solid. Okay, here put a, tesseract floating around. Okay, is that infinite? Infinite cube and infinite tesseract? No. Solids, any solid is a figure. It better have, borders, surface. Okay, so it better have some end to it. Okay, it's contained by boundaries. Okay, because again, Euclid said all figures have to be contained by boundaries. That better be true, whatever boundary is, right? And physics, all of these spheres, cubes, cones, etc., have boundaries, and no solid is infinite. Okay, and again, it's the religion of math, phys, that turned all these things into infinite things because they wanted to do math. They wanted to do itineraries and not figures. That's where the problem is. Okay, so let's continue here. We have a gentleman. His name is Victor Toth. I think that's how you pronounce his name. And he's quite popular in Quora. He answers questions from a point of view of the establishment, the mathematical establishment. And he makes all these same errors. You can see it, in every one of his writings. He makes every single error known to man, known to mathematical physics. Okay, and this is where he starts. This is one point that he pulled out the other day. Imagine the Euclidean plane. It is infinite. Absolutely not. There's no plane that is infinite. Okay, but that's what he was taught, and he just repeats it. Okay, by rote. Just regurgitates it. No matter how far you go in the Euclidean plane, there's more plane beyond that point. Well, if that were the case, you would not be able to tell the difference between a rectangle, a square, a circle, a triangle, because, if it extends forever and you're in the middle of it, how do you know what plane you're talking about? In fact, you don't even know if it's a plane because you're on one side of it. You can't see on the other side because it extends forever. So you can't cross the plane to the other side. Okay, so there are many problems with their visualization. In fact, even if you're far away, right, you're this bird's eye perspective, and this plane extends forever, what is it? Even if it's, facing you, like a square would be facing you, if it's infinite, what are you staring at? Are you staring at a circle, a triangle? What are you staring at? The only way we can imagine these things is from a bird's eye perspective where you can see the whole shape all around. So there is no such thing as an infinite plane. What they're talking about is not figures anymore. Now they're talking about itineraries. You say, what if you go, running forever until even beyond your death, right? And you find no end. Well, we'll call that infinity. That's the way they work it. So they extended artificially the triangles, the lines, the planes, etc. And that's how they get away with all that nonsense, because they're doing stuff that is unrealistic. Does it solve problems in math? We don't care. It's got nothing to do with physics or with rationality. Okay, that's the issue. They're inventing some abstractions that cannot be imagined. Infinity cannot be imagined. And there's a reason for that as well. So there again, we put the plane has to be a figure, okay? And what they're talking about is motion, okay? They're talking about something traveling or, trajectories or whatever. They're talking about dynamics. They're talking about perimeters. They're talking about, going around the circle, not about the circle, okay? They're talking about, going around the circumference or whatever. Okay, so what does Mr. Toth continues? He says, supposedly that the universe is spatially infinite. We don't know for sure. I like that. But the mathematical model that best fits the data has zero spatial curvature, which implies that it's basically a three-dimensional Euclidean space. Well, there we have a three-dimensional Euclidean space known as a cube, right? And so what Toth is suggesting is that he's got this, an infinite one, and the infinite cube, he only sees the one end of it, I guess. We don't know what's on the other end because he says it's infinite, right? So the question is, can we have an infinite cube? And if you do have one, does it make any sense? What are you staring at? What are you imagining? What are you visualizing? How can you imagine an infinite 3D whatever? What is it? It's like, imagine Atom Man inside a table, right? But he's so little, he's got all these atoms around him. Well, he can't tell he's in a table. All he knows is there's a bunch of atoms, and they extend forever as far as he's concerned. They could be infinite as far as he's concerned, incalculable ones, right? But he cannot tell us that he's in a table or inside an elephant or inside a tree. I mean, what is he inside of? And this is where the problem is. These people want to tell you the shape of something from the inside. That don't work that way, Okay, and here he gets into more trouble, this Mr. Toth here, and he says, one of the many curious properties of infinity, 2 times infinity is the exact same infinity that it was before multiplying it by 2. So, he says, if you have one apple, you multiply it times 2, you have 2 apples. We all understand that. But now he says 2 times infinity is equal to infinity. And 3 times infinity is equal to infinity, and 1,000,000 times infinity is equal to infinity. Okay, we got a problem there because he says the next step, he says, though we can do mathematical operations involving infinity, infinity itself is not a number. Right, because infinity just means to count perpetually. That's what it means, okay? Number is the verb to count. That's what number means, okay? And the word number is a verb. It's not a noun. And so infinity is simply to count perpetually. That's what infinity is. So you can't say, I'm going to multiply that times 2. You're going to count perpetually times 2, eternity times 3. Is that the way it works in math? No. And the question is, if it's not a number, why do the mathematicians introduce it into math? I mean, if you have an apple, if infinity is a thing like an apple or a stick or whatever, you can say, okay, 2 times sticks, I get 2 sticks. 3 times apples, I get 3 apples. But 3 times infinity, if it's an object, you would have 3 infinities. But infinity is not an object. You can't use the word infinity like that. So what is infinity? Well, again, it means to count perpetually, and it makes no sense to say that you're going to multiply 2 times counting perpetually. Okay, that's where the problem is. These people never defined infinity, and therefore they get tangled in their own language. This is the problem. This is where it all bombs out, all the mathematical nonsense, such as, black holes, which the singularity is alleged to be, an infinite point, And on the other hand, because mathematics goes, our universe, according to mathematics, goes from infinitesimal to infinity. It starts out as singularity. We don't know how that singularity came in there. Maybe God put it there. Who knows? And then it goes to, infinity. So we have from infinitesimal to infinity. That's their. But they never define these terms. But they want to use them. That's the problem. See, so they say, oh, we're at infinity. We can do operations with infinity, like, divide by infinity, multiply times infinity, all that stuff, but it's not a number. So what are you putting? An elephant in there, saying 2 times, you're dividing by elephant, or multiplying times rock? Is that what you're doing? Obviously you can't do that. And so the word infinity doesn't belong in math, okay? Because what they're saying is counting incessantly. Okay, count all you want, until you die. So this is the problem, and they don't have language. They don't have the proper language to communicate their ideas. Okay, so here he continues, says, if I were to take this thing all the way to the extreme in the past, what actually happened in the very early universe, when stuff was very, very dense, nobody knows. Yeah, we do know, but mathematicians don't know. We can only go back so far using the science that we have. In other words, what he's saying is you take it the motion picture to the past. In other words, you rewind the videotape, and all the galaxies, all the stars, everything comes together. And at some point in the past, they even crunch together and no longer are galaxies or stars or anything. They become atoms. And before that, you have energy, I guess, this undefined word, mass, right? And you get all the way to singularity, which is what? A point where infinitesimal point that we don't know what happens there because the laws of physics break down. That's how they explain it. Whatever that means, laws of physics break down. Yeah, it's simply a way of avoiding the question. The question is very simple. How did God create, objects from nothing? And here we have it. Okay, you're in the Universal movie, so there you see it. There was nothing, and in the immediate next frame, there's no other frame in between those two, right? Between frame 1 and 2, the immediate next frame you have something. And all of this individual has to do is tell us how God, or with God or without God, we don't care how he does it, how that 0D, nothing suddenly popped into and have shape and be something. Okay, so we went from nothing, which is that which has no shape, to something which is that which has shape. And there's no time in between, okay, because that's the immediate next frame. So the question is, how do you do that? What's the mechanism? With or without God? You want to put God in there? Do it, no problem. I want to see the mechanism. How did God do that? Okay, your God or whatever. And yeah, they cannot explain that. Okay, so that's the problem. Okay, and then he continues here. Finally, he says, well, it is true that the simplest cosmological model, spatially flat, homogeneous, isotropic universe with trivial topology, whatever that means, right, implies an infinite universe, and this model fits the data reasonably well. It does not mean that we know that the universe is infinite. Our expectation is that the universe behaves rationally even beyond the boundaries of the observable region. So yes, in that case, it is not unreasonable to expect that we live in a spatially infinite universe. No, impossible, because what you have to do is define your terms, and you don't have to go out there with a telescope or anything to figure out whether a universe is finite or infinite. It's very simple. This is really baby stuff, and these people haven't gone through kindergarten. So here it is, okay? I'll answer him. It says, concept, a word that invokes and embodies two objects, or two words treated as objects, okay? Universe is a concept, not a physical thing. You can't talk about the universe because the universe is not a noun. The universe is a concept, and concepts are not nouns for the purposes of physics. What does universe mean? It means space and matter. That's what it is. When we use the word universe, we're talking about space and matter. Concepts have no size or extension, and concepts are neither infinite nor finite. Okay? So, yeah, we cannot have concepts with size. Okay? Love does not have size. Intelligence doesn't have extension. Love is not infinite. That's okay in poetry, but not in physics. Okay? We're talking about physics here. What is space? Space is that which doesn't have shape. Okay? An object is that which has shape. Space is that which doesn't. And space is a concept, means nothing, literally. Space is also not a thing, so therefore space can be neither infinite nor finite, and matter includes all the atoms in the universe, plus what they call energy, which are groups. So it's made out of the same thing, as we'll find out, the thread. And so matter involves all atoms and the ropes that interconnect them. Therefore, the amount of matter in the universe is finite. There's only so much thread in the universe, okay, that constructs all the atoms and the interconnecting ropes. Okay? So that's the argument here. Okay? But here, let's continue. Let's find out where all this leads. And here you have all these people from the establishment, famous people, people who make a lot of money, celebrities of so-called physics, mathematical physics actually. Lots of people, tons of people follow these things every week, every day, and they think they're getting their science shot for the week, you know, and you aren't. They say, oh, I learned a lot, and they haven't learned squat. And so here you have them. They talk about the observable universe, the true shape of the universe, the scale of the universe, and above all, you know, the fact that they're talking about the size or shape of the universe. The space, really, that's what they're referring to, right? And here you have another set. Okay, all these people talk about whether it's flat, it's curved, whatever. All these videos are out there, and they get thousands and even millions of hits. And what are these people learning? I mean, can anyone tell us what the shape of the universe is? Or even before that, if it's big or if it's infinite? Because big is not infinite, okay? Infinite is a little different than big. And again, you can't have an infinite universe first, because universe is not a physical object. They talk about infinite space. Space is not a physical object, that which has no shape. So space can neither be finite nor infinite, because it's a concept. So is universe. So you can't talk about, you know, the infinity or the infinite universe or infinite space. These are irrational terms. Concepts are not infinite, okay? So what can we talk about? Well, we can talk about matter, you know, if that's what we have out there, whether the matter forms some kind of pattern, some kind of shape. Okay? That we can talk about. But space and universe, they're neither big nor small, or infinite or finite. Yeah, they're not objects, they're not things. And these adjectives such as infinite and finite can only be used in the context of physical objects for the purposes of physics. Okay, so here we have one fellow. He says he thinks that the universe looks like a bowl of cereal. Oh, that's great. All the galaxies and stars there in the bowl, you know, you can eat them up any time you want. Okay, so we have these people. They come up with all these nonsense, and they get thousands of hits, right? So whoever, I guess someone out there enjoys this. I guess they're not getting any shot of science in their arm. They're just getting nonsense, entertainment. That's all they're getting. Here's another fellow, and he says, it's commonly thought that the universe is infinite. But have you ever thought about what the actual shape of an infinite universe looks like? No, it's impossible. If it's infinite, you cannot talk about the shape of something that is infinite, and that's the issue. And here he talks about, you know, having saddle shape and all these other different shapes, you know, donut shapes and so on, and they don't have the slightest idea. And you have to remember, there you can see right in the center, you'll see the Big Bang explosion there, okay? And you can see how the universe is expanding there. And so you would think it's spherical because, you know, there was the Big Bang right there at the center, and it's pushing all the galaxies outwards. So this is their original model, you know. But as you will see today, we're going to change that a little bit. These people are going to change it, okay? So, but I like how this fellow ends. He says, not likely. Its true shape isn't something that we can necessarily define or grasp. Yeah, we can grasp all shapes, believe me. Any shape that you put, you know, on your screen, on the paper, on blackboard, we all understand it. Believe me, yeah. Shape is easy. It's kindergarten stuff. Don't tell me that you cannot comprehend shape, that, oh, I don't know what shape it could have. We'll just put it on the board and we'll know what shape it had. What do you have in the back of your mind? Give us a proposal. What do you think it looks like? It's very simple, actually, right? Okay, so here we have another fellow. I think it's the same fellow, but he says the following. The fabric of space, according to Einstein, is a plane with gravity bending and curving that plane. But this plane of the universe isn't completely flat. It's curved ever so slightly. We don't see it with the naked eye because we're just incredibly small. Even if we were able to somehow visually see the fabric of space as a literal flat plane, we wouldn't notice the curvature because we're simply too small. Well, this is absolutely wrong, erroneous, false, okay, in a sense. We can't use that notion that he just said there, the warpage of space to explain gravity, because we can't use it here on Earth. We can't use it to explain why a spoon falls to the floor. Because in order to explain that with this mechanism that Einstein proposed and everybody else just swallowed, is that you would need to have, in that region where you see the spoon falling, you would have to have the canvas be bent locally. And Einstein doesn't propose that, okay? General relativity is only used in the macro scenario, cosmologically. You can't use it here on Earth. You can't say, I'm going to bend space-time here in my garage or in my apartment or my living room. You can't do that. It's not a theory. It's not even a theory. It's the mathematics that Einstein put in his field equations cannot be used in a small location. Okay, so you cannot explain that with Einstein's theory. You cannot explain why the spoon falls to the floor. You can't do that. Okay, Einstein designed his theory for cosmological scenarios, the macro universe, right? Not for little things. For that, you need to use quantum. Quantum has yet to find gravity, mass, everything. They have no idea about anything of how it works. All they have is math, but descriptions. But they don't have any explanation that passes rationality. That's why they say, well, we'll never comprehend this universe. We don't speak the language of Father Universe or whatever. However, they get away from those questions. Okay, so here one fellow says Albert Einstein's theory of general relativity is which allows for the curvature of space itself presents the possibility that the universe can take one of three distinct shapes: flat, closed, or open. And there you have them. Okay, there's the flat pancake type, or you could say a sheet of paper, spherical, and the saddle shape. Okay, those are the three that these people propose. Okay, and let's see which one gets the cigar. Okay. And here you have one fellow who says, we can calculate shape. Calculate the shape of a horse. I mean, they can calculate shape. And here it is, okay? He says, thanks to advancement in our understanding of the world, we can actually calculate the shape of the universe. And he says he infers it by the amount of matter. And then he continues, it could be saddle shaped like the previous guy, right? Shape of a four-dimensional sphere. Oh, what is that? I mean, a four-dimensional sphere, what kind of shape does a four-dimensional whatever have? And then the third possibility is it's flat like a sheet of paper and infinite. Okay? So if it's a sphere, it's not infinite. It's finite, they say, because, it's got edges. But, the sheet of paper, these sheet of paper that these people have, they're infinite sheet of papers. So, they put it beyond your ability to show anything, because you can't prove infinity, with some kind of experiment. So they say, well, it's infinite. And that's how they put away the question from you. They say, they don't answer the question. They say, it's infinite. And that means, I'm not going to answer your question. That's all that meant. Okay, and so here we have, let me illustrate his point here. And here we have a bunch of particles. You can think of them as stars, you can think of them as galaxies. This is the entire universe, okay? And we have so much density. Okay, so can you tell me, because of the density, right? Let's say we calculate the density exactly. Can you tell me the shape, if this has the shape of a horse or a tree or a rock? I mean, how can you calculate shape? What sense does it make to say that you're going to, by knowing the density, you're going to calculate the shape of something? I mean, these people have no clue whatsoever what shape is. Shape is what you learn in kindergarten. You point and you say horse, and everybody sees the shape of a horse and says, okay, I know what a horse is because it looks like that, what I'm staring at. That's how simple it is. But to say, let me see if I can calculate the shape of a horse through the density of all the atoms in his body. Okay. Good luck, Okay, here we have the tesseract. This fellow says, when speaking of the shape of the universe, however, it's important to remember that our universe actually exists in 4 dimensions. Aha, I see. So 4-dimensional, again, they put it beyond your ability to visualize it. Okay, they get rid of it. And really, they're not talking about 4 dimensions. They're talking about 4 number lines. Our universe is 4 number lined according to mathematical physics. And these number lines, they point inwards, I guess, right? Because we're locating something within space-time, right? So they're not talking about 4 dimensions. They're not talking about length, width, and height. They're really talking about 4 number lines and how they measure something and what numbers they're going to be putting in there. But they use it in physics. They bring all those concepts into physics, and they say there's this 4-dimensional stuff that you can't imagine. That's our universe. Great, I can't imagine it. Yeah. And so what they do, they have these hyperspheres and tesseracts and so on. There's your flat 4D tesseract universe. So I guess that's what it looks like, okay? So he says, so any shape we talk about are lower dimensional shapes that we can understand. Yeah, nobody can understand 4-dimensional shapes, and the reason we cannot understand, we don't understand shapes. We visualize them. That's why. It's not a question of understanding. Understanding, you understand certain concepts. But objects, we just stare, visualize, and say, okay, even the blind man can do it. He can visualize and say, okay, I see what you're talking about. You're talking about a cube. You're talking about a ball. You're talking about, a tree or whatever. That we can all visualize, okay? So when these people say they can't visualize, they can't understand, it means they have no clue. So why are these people putting stuff on the internet and, crowding, everybody out with the nonsense that they put out there? Okay, another fellow says you can determine all this, the shape of the universe with an experiment. Send the James Webb telescope out there and see what it can see, and maybe it'll tell us what the universe looks like. Yeah, from the inside. Again, it's like Adam Man. He's inside a rock, and he's trying to figure out what the shape of the rock is on the outside. You can't do that. You're Adam Man. You've got all these atoms all around you. How are you going to tell what's on the outside? Through the density? Is that the way they do it? And here it is. This fellow says, what shape is the universe? No one can be sure. Always they start there. Until we can step outside of the universe and walk around it somehow. So you got to be on the outside looking in. But he can tell you for sure that it's flat. He says, so while we all know the earth isn't flat, it looks like the universe is. So yeah, they have a flat universe. It's the Flat Universe Society, not the Flat Earth Society. Okay, we have the Flat Universe, and for some reason they always put that wormhole, or I guess it's the entrance. You can say it's the black hole entrance to the wormhole. What does that have to do with the universe? But see, all they want is hits, and they crowd out, the science with all this nonsense. They're just providing entertainment. That's all they're doing. And people think they're getting science. They're not. They're getting a carnival, clowns in a circus. That's what it is. Okay, here's another famous site on the internet and YouTube, and that's Minute Physics. And what do they say? General relativity predicts. They always predict, right? That space is not just emptiness. It's a physical dynamic thing. It's a physical thing. Space is a thing. Space can bend, it can ripple, and it can expand. Yeah, I guess that makes space a thing, right? And all you have to do is tell me what's on the outside of that space thingy to give it shape, right? All of these phenomena can be described by one idea, curvature of time. Oh my God, they're going to curve time. What do? You bend the seconds, the minutes, what is it? There's only one shape space can be, a giant hyper potato. Okay, so what does this potato head say? He said, we so far have no idea why our universe has the density that it does. When it comes to the curvature of the universe, our knowledge falls flat. Okay, so I guess his potato goes back to being flat. And yeah, they they have the contradiction between the expanding universe and the fact that it's flat. Which is true. And the way they want you to understand it is they say, look, if the ball is very, very big and you're sitting on the edge of that ball, on the surface, right? For you, it's almost flat, getting flat or near flat. That's the way they say it. So that's what we're talking about when we say flat, but you're really on a ball. Well, it's one or the other. Either you're on a flat sheet of paper or you're on a ball. They can't be both ways. And they want both worlds. They say, look, since the Big Bang, we've been expanding. We have the ball scenario. But the universe is flat because it's infinite. So we have both finite and infinity in the same concept. The ball is finite and the sheet of paper is infinite. And they want both scenarios, and they go back and forth. When you talk about the flatness, they say, well, if the surface is very big and you're very little, then it's flat for you. So that's how these people get away with all that nonsense. But I like good old Michio, and he talks about the origin of the universe. And obviously, if we have an origin of the universe that's been expanding, we're talking about the ball scenario, as you can see there on your lower left. You're talking about the balloon analogy. You're saying that the universe is like a ball, right? And so that's the shape of the universe if we follow Big Bang theory. But what they do, they make the ball so big, and they say, well, if you're sitting on the edge of that, then it's flat for you. But then that doesn't make the universe infinite. Only the infinite sheet of paper would make it infinite. But see, they want the best of both worlds. But he says the following, good old Michio here. He says, he's saying that the James Webb telescope now can see a little farther, and it's putting some of the theories that all these mathematicians have been living with for almost 100 years, and says that all of a sudden we realize that we may have to rewrite all the textbooks about the beginning of the universe. Why? Because right now we have 13.8 billion years ago or something like that, close to 14 billion years ago that they say Big Bang started, but now they're finding galaxies and other stuff out there that couldn't have formed so fast, and so they may have to revise the date in which Big Bang happened, push it farther back. Okay, and that's what he's talking about. And he gives an example there, saying, "Look, they shouldn't have existed 500 million years after the Big Bang." That's the sense he is, and so he says we may have to revise our theory of the creation of the universe. We're possibly looking at a universe that's much older than we think it is. Okay, so for many years they've been telling us, that it's 13.8 billion years ago, and now they're going to revise it and say maybe it's twice as much as that. And, they just keep with all this nonsense. No, it's very simple. Don't tell me how old the universe is. Tell me how matter came into being from nothing. And if you cannot explain that, your Big Bang theory is nonsense. It's poppycock. So don't try to shove it down my throat, okay? Very simple stuff. You just have to tell me how matter came into existence from nothing. With or without God. I'll even pitch God in. You need the devil and Mother Nature, Father Universe, we'll pitch them all in there. Tell me the mechanism. How does something come from nothing? That's all we need to know. And if you can't answer that question, there has been no origin to the universe. Matter has always been there because space is nothing and matter is something. One is that which has shape, the other one is that which doesn't have shape. And you cannot turn that which doesn't have shape into that which has shape from one frame of the Universal movie to another. That's how simple it is. So matter could not have had a beginning, ever. It's always been there. So what do we propose? Well, here we say we work with definitions in science so that we can understand, so we can comprehend what the person is saying. Once we define these terms, all these theories from mathematical physics die a sudden death. They have no chance whatsoever. Here it is, universe, matter and space. What is matter? Something. What is space? Nothing. Very simple. They're antonyms. Space is that which has no shape. Matter is that which has shape. We're done. That's how simple it is. Okay, so that's how we start. And now we can follow through, and what we're saying is that the so-called matter, right? Matter includes the atoms and not the energy, because there's no such thing as energy. We need objects to do physics. You can't do physics without objects. And so we say these so-called energy thingies that they had all these years, no, they were ropes that bind any two atoms. Okay, so all of it is made by a single thread. Okay, so what we do is we introduce the single thread hypothesis, the assumption. We're going to assume that this is all there is in the universe ultimately. What we have is space, which is the black stuff, giving background to the single thread, which is the bright stuff that you see there moving, okay? And what are we saying? That this is our universe? Well, yes and no. I mean, what we're saying is if you untangle every atom in the universe and every rope that connects any two atoms, this is what you would end up with. You would end up with a single, very extremely thin thread. That's all there is out there. Okay, so space and the single thread. That's all there is. There are no particles, nothing proposed by mathematics for the last 2,500 years since the days of the Greeks. All there is a single thread in all of space. And what does a single thread do? Well, it's already done, but we say that if we untangle every atom in the universe, we end up with a single closed-loop thread. And that's all there is. So if you started from one atom, any atom of your choice in the universe, and you had all the time, eternity, to walk around, you would, and nothing better to do, then you would go from one atom to the other, and you would come back to your original starting point, because it's a single closed-loop thread for all matter in the universe. And there's a basic model. We're saying that the threads make up the atoms and the ropes that interconnect them. And here you see the model up close, okay? That's what it is. You see that the 2D version and the 3D version. And they're connected by a rope made of the same thread as the atoms. And so what you have is atom to rope to atom to rope to atom to rope, and all around the universe. Okay, so that's our model. This is how it's constructed. Here you can see it real quick. Okay, you have one thread goes through the center of the atom, the other one goes around, forms the encapsulating electron shell. You have all the atoms in the universe connected to it with all these ropes, and that's what it looks like more or less. The ropes, one forks around the red one and forms the electron shell. There you see it. And the other one goes through the center and forms the proton star, okay, or dandelion as we call it. Okay, so that one is the proton, and that's the electron. Okay. That's our model. That's the proposal. That's what an atom really looks like. If we had the eyes of God, we could go down there in Atom Man's world. Okay, and so with this, we can make sense. We can talk intelligently to one another. Okay? Here you have the Universal movie, and this is good old Father Universe there, God, devil, whatever you want to call him. Okay, and he exists only in one frame. Okay, Father Universe, all the atoms in the universe, they only have location. They don't know anything about motion. Motion is an observer issue. Okay, the atom is here, and tomorrow it's over there. It just changes location. And if we take a cross section of time, which is what that frame indicates, cross section of motion, you could say also, all we have is location. What is motion? Bunch of locations. Okay, and so if we look at a single frame, all you have is static concepts. All you have is location of every atom in the universe, and that is Father Universe. Father Universe only lives or exists in the present. What does that mean? It means that he has all these atoms in the universe that comprise him, and he goes to sleep. He goes to sleep for 1 billion years. More or less like what is it? I forget his name. Well, he goes to sleep, and he wakes up 1 trillion years later, and suddenly he finds himself, awake again. He's every atom is now in the next location. Then he goes to sleep again. So Father Universe only exists in the present mode. There is no past or present according to Father Universe. All the atoms can only occupy one location at a time. Okay? And so, Father Universe only exists in the present. It is us humans who talk about motion and about time. No such thing in Father Universe's world. In his reality, it's just location of every atom in the universe. That's all there is. And so what does that mean? If we have space and we have matter, and you could, maybe take yourself out of there and try to look at all the matter in the universe, all the atoms in the universe, right? From afar, like from a bird's eye perspective. What would you see? And so here it is, okay? This is God, and he's going to look at the universe from afar, okay? And so there you have all the atoms. Well, yeah, they would form some kind of shape, right? We don't know because we're inside that little square, you could say, or cube there, with all the galaxies, all the planets, all the stars, right? We're in there, and we cannot tell what the shape of the entire bundle of atoms forms. We can only do that if we're, there with God, seeing it from afar. But since we're not, we cannot tell even from the density of that, what the universe looks like as far as its shape. And all we can do is say, look, all the atoms, form some kind of pattern, some kind of shape, and we'll never figure out what that shape is, not from our little point of view here in the center. We can't calculate it like these people say. All we can do is speculate and say, it could be spherical, it could be irregular shape, maybe it's potato shaped like that other guy said. Yeah, all those could be true, but what it can't be is infinite, okay? Space cannot be infinite, and neither can matter be infinite. The amount of matter in the universe is fixed, okay? And all we can do as far as the matter itself is say, look, the number of atoms in the universe has to be a certain amount, or the amount of thread that makes them up can't grow because the thread does not stretch, okay? And so the question is, the amount of matter is fixed, and our universe, in other words, the matter in the universe forms see, if you look at it as an object, it would have some kind of form if you could be outside there looking at the whole thing from, a bird's eye perspective. And that's all you can say. But what the universe looks like, you can't tell. And for sure, neither space nor universe can be infinite, finite, or whatever, because they are concepts.